So our next question is from GATE 2020 Instrumentation and Process Control for 1 mark. Consider the following closed loop system with GPGC as the transfer function of the process and the controller respectively. You can see here it is given that for a unit step change in the set point YSP, the change in value of the response Y at steady state is. So let's start with the solution. You can see here we can write it as in this form. You can see here what we can do. We write it as y over ysp is equal to pi forward loop upon 1. If there is a negative sign, then we will write it as 1 plus 1 plus all 1 plus open loop. Then if you open this loop, then you will get the open loop transfer function is just gcgp, right? So our transfer function will be like this: gcgp upon 1 plus gcgp. So if I put the values, then I got ys upon ysp. Ys I have write it as ys since it is a Laplace form, right? So so we will got this. Again, we know that unit step change in ysp, it will be equal to ysp is equal to 1 by s. If there is a unit step change, then it will be 1 by s, and I will put ysp is equal to 1 by s, then I got sys is equal to this. And we know that final steady state will be sys at s tends to 0. From the final value theorem, you know that when t tends to infinity, then s tends to 0. So we can put s is equal to 0, but you can see here there is a one problem. If I put s is equal to 0 here, then it will be infinity, and here also 1 by s form. If s is equal to 0, then it will be infinity. So I can do one thing. I will multiply s in numerator and denominator, then I will get this if I multiply s, right? So I will get this, and I will put s tends to 0. If I put s tends to 0, then I got, after solving this, 1. So it is our final answer. So please make sure to like, share and subscribe. Thank you.